All right, so I want to welcome all of you to today's section. Today we're going to talk about some few things before we delve into practical section on machine learning. We'll look at classical machine learning today, and hopefully next week we'll take a look at quantum machine learning. So let's look at some recent trends in quantum computing and research opportunities. So there's the outline, introduction to quantum computing, current use cases, future applications, research opportunities. So as you are all aware, quantum computing is becoming more accessible through various deployment models like UCAS, that is quantum computing as a service. And quantum computing as a service is a specialized form of IaaS that provides access to quantum computing platforms. So one example has to do with the IBM quantum experience. And the IBM quantum experience allows users to run quantum algorithms on actual quantum hardware and their simulators. So there are various services that we can access our quantum computing resources, software, and other things from. So we have quantum computing as a service, we have platform as a service, which also offers a platform with tools and libraries for quantum programming. For example, Microsoft Azure Quantum is one great example. We also have algorithm as a service. So algorithm as a service delivers specific quantum algorithms as a service. For example, we have the D waves, that are the D waves. So these are all services that we can look at, and we need to understand the difference between what quantum and classical computing is all about. So for quantum computing, we already are aware that we are dealing with qubits, which can represent 0 and 1 at the same time. So we are looking at a superposition of states. But then if you look at classical computing, we are looking at transistors, and no transistors can either store a value of 0 or 1. So it's either 0 state or 1 state at any particular point in time. Also, you are all aware as of this time that quantum computers have high error rates. And then for classical computers, you have low error rates, maybe probably due to the fact that they have been in the system for very long. So with time, I'm sure quantum computers will also have very low error rates. Now, recently, there's a research that was conducted, and Qiskit outperformed most of the SDKs when it came to performance. So that research was entitled Qiskit Leads Quantum Software Development Case in Performance. All right. Qiskit was compared to other SDKs. It was found out that Qiskit had very good performance. If you look at the diagram below, you will see that Qiskit was compared to Bracket, was compared to Sec, and was compared to Ticket. And then we're looking at the, the speed of building circuits, manipulating and transpilation. So all of this came into consideration when we talk about the building of circuits, the manipulation, and the transpilation. Then Qiskit had a time of 7.47 seconds, and that shows that it outperformed the rest of the SDKs that we have. So Qiskit has made a very significant progress, but then it's just a matter of time for us to see who actually has the quantum advantage. So quantum computing has often felt like a theoretical concept for some time now because um, because we have not seen any significant tries. We have not even seen what quantum applications, what we can use quantum computing for. So we are not seeing the application aspect of quantum computing. So people are usually thinking that it's just a theoretical concept, but it is far more than that. Um, It's understandable because quantum computing is in its inception, it's at the early phases, stages. So it's going to take some time to actually realize its full potential and what it was meant to do. So some current use cases of quantum computing include artificial intelligence. So we can use quantum computing in AI, and in artificial intelligence, you can even look at machine learning, for example. We can use quantum computing in better batteries, cleaner fertilization, cybersecurity, drug development, financial modeling, weather forecasting, and climate change. So these are some application areas of quantum computing. Now, I must also indicate that quantum computing has a lot of areas it can be applied to. It's not only limited to these 10, actually. So, what is the future of quantum computing? Now, business leaders have begun to look into the adoption of uh, computing here and there in order to advance their activities and their business processes and all of that. So you realize that for some time now, we have seen the adoption of generative AI. And generative AI has to do with ChatGPT and all of that. We have seen a lot of uses when it comes to generative AI. And that has taken the headlines in the year 2023. But then we have to also be careful because quantum computing is also just around the corner, which we have to pay attention to because it's going to um, help transform the society that we live in. It's just a matter of time. So, what are some key takeaways? Quantum computing may be the next shift we see worldwide. Currently, engineers are focusing on the qubit quality and error correction because if you look at the qubits are susceptible to noise, especially the physical qubits, and they are susceptible to noise, errors, and decoherence. And that is as a result of the environment and all of that. So before quantum computing can be very, very useful, it means we have to limit the extent of errors in the qubits. And that has led to a field called error correction. So we have engineers, professionals who are actually trying to reduce the errors in the qubits so that it can be meaningfully used for what it was meant for. Now, we also have an issue of data security, which um, has come about as a result of quantum computing because the current encryption standards that we have, if quantum computing has the potential to actually crack them or to break them. So this has led to the development of encryption algorithms so that we can help curb this situation. So sectors such as finance, pharmaceuticals, sustainability, and regulated industries are exploring the potential impact of quantum computing in their respective fields. So that is what it's all about. Now, there have been some development roadmap since 2019 to now. Things are ongoing when it comes to the field of quantum computing. For example, IBM Quantum, from 2009, they started to run quantum circuits on the IBM cloud. In 2020, they demonstrated prototype quantum algorithms and applications. 2021, we see them running quantum programs faster with Qiskit runtime all the way to 2024. So there are various development roadmaps that IBM Quantum has been undertaking. So if you look down here, we even have various quantum computers that have been developed. Falcon, 27 qubits, Hummingbird, 65 qubits, Eagle, 127 qubits, Osprey, 433 qubits. And I learned recently there was the release of the Condor, that is 1,121 qubits. But then mostly it's the eagle and the osprey and hummingbird that is being utilized. I'm not really sure Condor is being used now, even though there has been information that it has been released. So Atom Computing's recent announcement of a 1,225 qubit quantum computer, nearly tripling the IBM's Osprey. You know, IBM Osprey was 433 qubits. So we have 125 qubits. It means it has tripled that of IBM's Osprey quantum computer. So, and this leap amplifies quantum computing's potential to actually transform areas like pharmaceuticals, cybersecurity, and hence enabling calculations of unimaginable complexity. So, for quantum computing, we must not just look at the quality of qubits, but must also look uh, not just the quantity, but the quality. Because we see day in and day out that we are having 27 qubits. Then for 27 qubits, we saw an increase in qubits to 43 qubits, which is the Osprey. And it is not just about coming out with a quantum computing with a high number of qubits, but then we must also look at the quality of these qubits. What do we mean by quality? We must try as much as possible to reduce the noise and the errors in them so that they become meaningful. So that is what we need to take a look at. Quality qubits over quantity is very, very essential when we're talking about quantum computing. So we must also look at the development of quantum resistant encryption methods because it is no longer an option, it's now a necessity. Now that quantum computing is on the scene, we need to develop encryption standards, methods, protocols that are very resistant so that they can be able to curb any threat that the quantum computer can potentially pose. So it's very, very important, and that has been what has been happening. So we have NIST that have been working on that. They have released the final set of encryption tools designed to withstand the attack of a quantum computer. So if most of you have been following NIST, you know that they are also into the standardization of protocols, encryption algorithms, anything that has to do with standards, protocols worldwide. NIST has the ability to do that. So they are responsible for those standardizations and all of that. So NIST calls for adoption of the new standards that so these new standards actually make use of mathematics because they are basically encryption algorithms and they make use of maths to protect sensitive electronic information, including websites and emails. So it's very, very, very important that we adopt these new standards that has been released by NIST. Now, the new standards are designed for two essential tasks for which encryption is typically used. So we are looking at general encryption used to protect information across a network and all of that. Then we also are looking at digital signatures used for identity authentication. So NIST announces selection of four algorithms, that's the Crystal Skyber, the Crystal Dilithium Sphinx, and Falcon. This was slated for standardization in 2022, which we saw, and draft versions were also released in 2023. So we had a fourth draft standard based on Falcon, and this was planned for 2024. That is this year. Now let's look at some misconceptions around quantum computing. Some people have the idea that quantum computing is something of the future and it's not something of the present, but let's clear that misconception. Quantum computers are actually in use now. It is not 10 or 15 years away. We have universities, big organizations like Google, IBM now developed the quantum computer, which is in usage. It is only our part of the world because we don't have access to the quantum computer. We are making use of the quantum computer through the cloud. So we are making use of cloud resources to access the functionality of the quantum computer and all of that. But then is actually in use in some organizations. So what sectors will quantum computing impact? It's going to impact various sectors like the financial services, it's going to impact pharmaceutical industry, it's going to impact various sectors across the economy. So we're also looking at healthcare. Quantum computing also impact healthcare. It's going to impact aviation. It's going to impact finance. It's going to impact agriculture and a whole lot of areas. Now, what's the future of quantum computing? So, quantum computing is not a futuristic concept. It's a current reality with some milestones that have been achieved so far. So, it is better and important that we focus on quantum technology and use it to come up with meaningful applications that can help society and transform society into actually also achieving the sustainable development goals that have been set by the United Nations. And that's very, very important. So quantum computing is on the horizon, and then everyone must get involved in it. So what are some of the challenges in computing? Obviously, one of the challenges had to do with the fact that there's limited hardware across the world, just few organizations that have quantum computers. So basically, most of us are just accessing it through the cloud, and that's one challenge. The second challenge is that currently quantum computers have some noise, which is um, being rectified. So engineers and professionals are working on it to reduce the level of noise in there. And that has led to what is known as logical error-corrected logical qubits. So they are moving away from the physical qubits to error-corrected logical qubits, which has the potential to actually detect and correct errors. So very, very important. Quantum computer has made significant strides in its effort to actually revolutionize things, computing here and there. So very, very important. I want us to start to move very fast so that we can start with some practical session. So pardon me if I'm moving too fast. So what are some of the challenges also? Quantum computing could shatter current encryption models. So the current encryption models, security protocols we have, quantum computing could shatter it. And that is as a result of what they saw in the Shor's algorithm. Shor's algorithm was able to show that encryption algorithms and protocols could be broken. Hence, there is the idea that quantum computing could actually break current encryption. And therefore, they need to develop quantum resistant or post quantum cryptography encryption standards, algorithms, protocols in order to handle this situation. Yeah. So I talked about the physical qubits and that we are now moving on to the error corrected logical qubits, which is very, very important. These are some differences between physical qubits and error corrected logical qubits. As I said, one is accessible to noise, the other is designed to detect and correct errors. So that is basically the main difference. But then there are other differences that are in there. So we have some collaborations in industries worldwide that is ongoing in order to make sure that quantum computing reaches wherever it's supposed to reach in order for us to achieve um, the essence why quantum computing was actually developed. So, and you know that for quantum computing, you can't sit in your room and think you are an expert and you do everything by yourself. There have to be collaborations here and there if you are to be abreast with the latest advancements and updates when it comes to quantum computing. Now, next year has been declared the International Year of Quantum Computing, as you all know. Must all do our best to actually partake and undertake in activities that will help that will help achieve the SDGs, the Sustainable Development Goals that has been outlined by the United Nations. So that is it. Um, So for those of you who want to look at various research and education funding opportunities, you can look at Unitary Fund. Unitary Fund provides research and education funding opportunities. We also have Open Quantum Institute that can also provide support and funding to some quantum computing applications or projects that you want to undertake. We also have, yeah. We also have the US National Science Foundation that also can support with proposals and research education that you want to undertake. So if you have any research proposal, educational proposals, you can submit them to these organizations, and if your proposal is very, very good, then they can support you with funding here and there. So we also have scholarships and awards. If you want to get scholarships and stuff, the Institute for Quantum Computing does that. University of Waterloo also gives scholarships and awards to students who want to undertake postgraduate studies in quantum computing and so on and so forth. So That is very, very important. We have the government of Canada, who also have what we call the Applied Quantum Computing Challenge Program, where you can partake in this particular challenge. And then you end up positioning yourself in quantum computing and also getting some funding here and there for certain projects you want to undertake. So that is some of the organizations. Now, what are the top 18 institutions leading quantum computing research in 2024? Obviously, number one is IBM. We have Massachusetts Institute of Technology. We have Harvard University. We have Max Planck University. We have various institutions that are into quantum computing. Aside IBM, we have Google SEC. Google is also into quantum computing with the SEC technology. We have Penny Lane. We have the Amazon, the Bracket. We have various quantum computing platforms by various different organizations. Right? We can take a look at. So let's take a look at the next session, which has to do with the overview of machine learning. So
Please wait. Please, can you
yeah,
give room for questions?
okay. If there are any questions, kindly give you can talk about it so that I move quickly to the next phase.
Please, you can unmute yourself and ask your questions.
Okay, thank you. Please, I want to ask how to a layman, how quantum computing can be explained to him or her.
Is that how
Thank
quantum
you.
computing can be what?
Explained to a layman.
Okay. So
Thank you.
yeah, thank you very much. So explaining quantum computing to a layman, maybe we don't have to go into the technicalities, meaning that we just have to let the person know this is a new computing paradigm where things are not going to be of the usual norm. So we are basically looking at exponential speed ups in the things that we do. It means if you are doing something, we are looking at fast processing and optimization of tasks. So maybe when you are explaining quantum computing for a layman, you should let the person know that there is this computing that is coming that is now very, very fast, very, very exponential, and that's going to help us do a lot of things quicker and faster than the current form of computing that we have. So that is the the way to explain it to a layman.
Hey, thank you.
Yeah.
Hello. Hello.
Yeah.
Hello. Please, quantum computing and quantum computer. Actually, when it comes to data electronics, they're able to see hardware that they can relate. But when it comes to quantum computing, it's very difficult to uh, 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 even visualize how the quantum computer looks like. Is there any picture or any design that one can relate to so that when dealing with it, it will not be too abstract as some of us see it?
Okay. I see. There's actually images of a quantum computer which I can show you. Maybe I think I didn't place them in any of my slides, but I can quickly show you online how the quantum computer looks like right now. So let me just go online. A quantum computer. Okay. So quantum computer are being developed by different organizations, so they might not look the same depending on the organization that's developing it, because there are various technologies that are being used to design the quantum computers. But these are images of a quantum computer. So we can have a quantum computer in this format. This is a quantum computer. This is also a quantum computer. I hope you can see the images.
Yes, we can
Yes,
see,
sir. I
please.
can see that.
Yeah. So that is a quantum computer. It is very huge. You have to actually hang it. It can occupy a small room. So it's just like the way classical computing began. When classical computing began, where the computers were very huge, where they could occupy a particular room. But with time, you realize that the sizes of computers have reduced drastically, and the performance has increased. The computational capabilities has also increased. So that is what has also is also beginning to happen with the quantum computer. Quantum computer is also starting like that. It's very huge, but with time, um, I'm sure the size will reduce and it might be accessible to all of us, like the way we have computers being accessible to us right now.
Okay, thank you, sir.
Any more questions?
Yeah, please, about the picture showing. I'm just wondering where maybe keyboard and then mouse and those things, where they are. I'm just wondering. Hmm.
Yeah, that's what I said. Um, it is does not gotten to the level where you can be using keyboard and all of that. But there
Okay.
is a way you can feed the quantum computer with an input. It will process the input and give you an output. So
Oh,
it is not portable now, such that you can type in, you can use keyboard and all of that. But you remember even the start of computers when it used to be very huge. There were not really any keyboards and stuff. People had to actually go there, go and connect a certain device to the computers in order to perform their functionality and processing of tasks here and there. So, yes, we can access this quantum computer through the cloud. So there are cloud resources that enable us to access this quantum computer and use it for whatever purpose you want to use. So those of you who are actually into quantum programming, you understand. Some of you have probably written circuits in Qiskit. Some have written circuits maybe using Penny Lane and so on and so forth. And you notice that these are various platforms that accesses the quantum computer and whatever you're trying to do. So you can actually use the quantum computer from the cloud without actually coming into physical contact with it.
Papa phone bi wɔ hɔnom a
You understand?
yes, please. Yes, please. Thank you. Thank you so much.
So can I progress?
Please, I think there's a question in the chat section.
Okay. Uh, what is the question?
I can read it. You're hearing though. It says,
Okay, so
please,
please,
okay.
how can quantum computing improve the accuracy of climate models compared to classical computing methods? Oh, okay, I see. So, usually, some of these climate models, depending on what you are trying to do, if it's a machine learning model, then obviously there are classical machine learning methods you can use. There are also quantum machine learning methods or models you can use. So when you use these models and methods to run your data, then you can check for the accuracies and stuff. So actually improving accuracy is not really about whether you're using classical or a quantum computing model. Sometimes when you run your data through a model, you have to even perform some tunings here and there, like hyperparameter tuning. You need to check your data, ensure there's not the data is well structured, there's no data imbalance, and so on and so forth. So all of this actually contributes to the accuracy of your prediction. Now, accuracy is just one of the metrics when you are actually doing measurements when it comes to models. So we can talk about accuracy, we can talk about precision, recall, F1 score. All of those are metrics that can be used. So, as I said, because quantum computing has the ability to be in a superposition, that is being 0 and 1 at the same time, it is believed that it's going to perform faster compared to classical computing. Hence, when we get a very functional quantum computing, quantum computer, very functional one, void of noise and all of that, we are going to see that it's going to be very fast compared to that of classical computing. Because just imagine, something processes information 0 or 1 state at any point in time. Another thing also processes information 0 and 1 state at the same time. Which of them do you think that is going to process the information faster? Obviously, the one that can process the 0 and the 1 state at the same time. But then, as I said, there are challenges that are being addressed right now. When those challenges are addressed, quantum computers would be exponentially faster than classical computers. And therefore, it means that it's going to affect anything, any models that you might also run on the quantum computers as well. All
Hello,
right, thank you very much.
hello, sir.
Yeah.
I wanted to ask, so the pictures you showed here, they are basically just like, they are quantum processors, like, just like a CPU, right? Just that is launched on the cloud for people to use.
Yeah, you can, it's launched on a cloud for purchase, but those who have access to this physical hardware also have a way of actually accessing it without the cloud.
Okay, so right now, what we for us, for let's say for us, if we are going to use it, we are basically combining classical computers, using classical computer to access it, right? So like it's currently like quantum classical.
Yeah, so I agree with you because as it stands now, what we are doing is not fully quantum computing. We have not moved to the era of fully quantum. We are actually still leveraging on classical hardware, classical laptops, classical software, classical this, classical that in order to access the quantum computer. So if you really check, we have not even moved into full quantum computing. We are still using classical resources to access this quantum computing. Until a quantum computer is fully developed, functional, and we have access to it and we are using it for our tasks, we can't say we have moved fully quantum.
Okay, thank you.
Yeah. Any other questions? Okay. So if there are no other questions, let's move on to our next slide. Let's look at an overview of machine learning. I hope this slide, you can see it. I hope it's clear. All right. So, overview of classical machine learning. So, as you are aware, machine learning is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models that enable computers to perform tasks without explicit instructions. So, sometimes this machine learning algorithms, you have to actually give it data because it actually relies on data. The data could be images, it could be audio, video, it could be textual data, it could be any form of data. So, what are some examples and use cases? Now, machine learning is typically the most mainstream type of AI technology. If we talk about artificial intelligence worldwide, mostly they're actually talking about machine learning, even though we have other aspects of AI like robotics and all of that. But you will see that principally machine learning is one of the widely used in the world. And most of you have been seeing sometimes when you're on the internet, you see certain features or functionalities suggesting products to you, or suggesting certain songs to you, or suggesting certain movies or videos to you. Those that is actually made available because machine learning is in place. So we have recommendation engines or recommender systems that actually can suggest products to you for you to purchase or to take a look at and all of that. We also have speech recognition software that allows you to convert voice into text. Machine learning also helps in fraud detection when it comes to the bank. So banks fraud detection services. We also have machine learning algorithms, AI technology that is fused into vehicles here and there in order to detect blind spots and so on and so forth. All of this also enhances vehicle safety and all. So machine learning has a lot of use in the world today. So if you look at machine learning, principally there are three aspects of machine learning, or you want to say types. Supervised learning, unsupervised learning, reinforcement learning. So if you look at supervised learning actually uses label data, and then you realize that under supervised learning we have classification and regression. So classification, we can have image classification, customer retention, diagnostics, identity fraud detection, and so on. These are some of the classification tasks that can be performed. We also have regression activities that could be performed, like market forecasting, weather forecasting, estimating life expectancy, population growth. These are regression tasks. We have reinforcement learning that can be used for real-time decisions, robot skill acquisition, and so on and so forth. We have, under unsupervised learning, we have dimensionality reduction and clustering. So under clustering, we can have recommender systems, customer segmentation, targeted marketing, and so on and so forth. So these are example of use cases that machine learning, which falls under AI, can be used. But then for our practical session today, we are going to look at supervised learning, especially regression. Now, under regression, we are not going to look at weather forecasting. We are going to look at financial forecasting, how to forecast financially. And when we get there, we'll see how it is done. So from every machine learning, basically there are three main components. We have the input, the process, and the output. Every machine learning model must be fed with data. The data must be processed, and then it has to give us an output. So that is how machine learning works. So we have a typical model like we have in the following. And this model, as you can see, we have input data. The input data is fed to the machine learning algorithm. And then this machine learning algorithm has a model. Now, this model actually accepts data because the data has to be split into the train set and the test sets and all of that. So when the model actually trains the data and everything, then it can make prediction, and then we can have some evaluation afterwards. So this is how the machine learning model actually works. So someone said, then what's the difference between machine learning and deep learning? So deep learning is just a subset of machine learning. Machine learning is a broader set, or is a universal set. So it refers to the general use of algorithms and data to create autonomous or semi-autonomous machines. Whereas deep learning is just a subset of machine learning that layers algorithms into neural networks. So if you have heard, you will see some talk about the recurrent neural network, convolutional neural network. All the neural networks are actually deep learning technologies. And neural networks were designed such that it will somehow mimic the human brain. So that is how machine learning operates. So as we said these are the types of machine learning: supervised learning, unsupervised learning, reinforcement learning. So in supervised machine learning, algorithms are trained on labeled data, and that is very, very important. So supervised machine learning is often used to create machine learning models used for prediction and classification purposes. So it's very, very important to take note of that. Well, for example, we can have an algorithm that may be fed images of flowers that include tags for each flower type so that it will be able to identify the flower better again when fed a new photograph. Or we can have some data that has images. The images are actually labeled. Maybe we can have various types of widths, and we can see that each of these images is labeled. The width type has been labeled on the image. So also to guide the machine learning model to be able to know, in case we now feed in with a new information or image, able to detect what kind of width it is. So that is what we refer to as a labeled data. In supervised machine learning, algorithms are trained on labeled data. But on supervised machine learning, the training is done on unlabeled data. This time the data is not labeled. So we allow the model to actually try to reduce patterns, to reduce the structure, to identify patterns within the data in order to make predictions and to actually give us certain outcomes or outputs. So that is the difference between the supervised and unsupervised machine learning. Now, semi-supervised, this is one actually type of machine learning, but it's not really talked about. This one combines both functionality of the supervised and unsupervised machine learning. So there are some situations whereby you might decide to use both unlabeled and labeled data to train your machine learning algorithms. In that case, then it falls under semi-supervised machine learning. So we also have reinforcement learning. Reinforcement learning uses try and error to train algorithms and create models. So there's some kind of a try and error approach, but then it is not just try and error, because it also has a mechanism to be able to learn from the errors that it has committed in order to give better outcomes as it moves ahead. So during the training process, algorithms operate in specific environments and then are provided with feedback following each outcome. So much like how a child learns, the algorithm slowly begins to acquire an understanding of its environment and begins to optimize actions to achieve particular outcomes. So reinforcement learning, for example, an algorithm may be optimized by playing successive games of chess, which allows it to learn from its past successes and failures playing each game. So one advantage of reinforcement learning, it learns from its previous failures and successes in order to come out with better outcomes and predictions here and there. So these are still some application areas that we looked at earlier on in another format. So what are some of the benefits of machine learning? What are some of the risks? No, machine learning is already transforming much of our world for better today. It has been used for a lot of things, a lot of areas in our society. We see machine learning in agriculture, machine learning in finance, machine learning um in health, machine learning in various sectors of the economy, and it's actually helping. So what are some of the benefits? Well, with machine learning, there's decreased operational cost, because if you can get AI and machine learning to be doing certain things, then maybe it is going to automate some of the jobs. Hence, you might not need to be employing people, and that might lead to job layoffs. So that is a danger of machine learning. It can easily take the job of somebody, because the job that you are supposed to do, if machine learning cannot do it, then what is your use as an employee? They don't need your services anymore, and therefore you can be laid off. And that is a fear about machine learning. But then its essence is actually to make our work simple, and so on and so forth. So we also have some benefits and dangers there that you can look at. Now, machine learning model life cycle. So anytime you want to undertake a machine learning activity, you need to follow this life cycle. One, you need to define the problem. What problem are you trying to solve? What are you trying to do? You need to define the problem. You need to collect and pre-process the data. So after defining the problem, you need to collect your data. And after collecting the data, you have to pre-process them. You have to process them, make sure the data is intact, is in the right format, is well structured, and so on and so forth, so that you don't have any issues or don't encounter any issues subsequently. Number three, you will now choose your algorithm, because there are various machine learning algorithms that are in use today, and you have to select one of them depending on the task or activity you are trying to do. It is not any algorithm at all that you can use for any task. So you have to be very careful the kind of algorithm that you are using for a particular task. Now, after choosing the algorithm, you now train the algorithm with the data that you collected and you perform pre-processing on. So you need to train the algorithm using the data. After that, number 5, you evaluate the model. And in evaluating the model, that is where you have to come out with some metrics here and there. If usually for classification tasks, you have metrics like accuracy, recall, precision, F1 score, and so on and so forth. But when it comes to regression activities, then the metrics you might be looking at probably root mean squared error, the mean absolute error. Those things are the metrics for regression activities. So yeah, number 6, you will now improve the model. So after evaluating the model, you know the model it has good metrics or not. If it doesn't have good metrics, you have to actually tune certain things here and there, make certain changes here and there, and make sure that you improve upon the model. When a model is running optimally and there is convergence and everything, then you can now deploy your model. And in deploying the model, you might probably deploy it using a mobile app or a web application so that non-technical users can actually make use of whatever system you have designed. Probably you have designed a system to predict something, so there should be a way users can access your system to do that. And that is where the deployment of the model comes in. So for mobile apps developers, you might probably be deploying a model using Flutter. This is a platform for developing mobile apps. So, and so on and so forth. For those who be indulging in web applications, probably you might be using React, JS, and so on and so forth. So it all depends on where you want to deploy your model. So machine learning in finance. Machine learning in finance is used to analyze data, it's used to optimize decisions, and it's used to make predictions. So we can look at trading, risk management, investments. These are places where we might need optimization of decisions, and therefore machine learning can play a crucial role when it comes to trade, when it comes to risk management, when it comes to investments and all of that. So these are some applications of machine learning. We also have certain applications of machine learning in finance industry. In the finance industry, machine learning could be applied for client profile management, automation of operations, fraud detection, efficient risk assessment, intelligent trading, effective data management, advanced marketing, and so on and so forth. So there are various use cases in finance for machine learning, and that has to be understood. So there are some business benefits of machine learning. One is enhanced decision making, improved customer experience, increased operational efficiency, personalized marketing, enhanced security. These are some business benefits of machine learning. Right. So this brings us to the end of the second session, which is an overview of classical machine learning. If there are any questions, kindly ask them so that I address them before moving on to the last session, which is also practical oriented. Yeah. Any questions? Are there any questions?
No, I think.
Okay, then let me move to the third session. So the third session is prediction of Ghana's economic health using classical machine learning. If I will look at classical machine learning today, and if you're able to finish it, we'll look at quantum machine learning next week. But if you're unable to finish this, we might continue next week and then move on with the quantum aspect as well. But I'm hoping that we'll finish this today. So let's take a look at that. So We're going to actually, what we are going to do is we are going to look at how we can predict Ghana's economic health. All right, and we're going to use one classical machine learning algorithm or technique. So if we know that in economics, there are various microeconomic indicators that are used to check to see if the economy is good or not, or if it's performing or not. And the finance guys are well versed in this. One of them has to do with the merchandise trade flow. We also have what is known as financial soundness. We have exchange rates. We have commodity prices. We have interest rates. We have government fiscal operations. We have balance of payments. We have various macroeconomic indicators that can be utilized. And every country might have the macroeconomic indicators that they actually use for their economy. But we have macroeconomic indicators that also cut across all economies. But here, we are going to adapt the macroeconomic indicators of the Bank of Ghana, the central bank. Yeah, so the central bank or Bank of Ghana has various macroeconomic indicators that I use. We might not be able to look at all of these macroeconomic indicators because there are a lot. We're just going to pick one of them for our classical computing machine learning activity, and the same also for quantum machine learning. And so we'll take a look at the merchandise trade flow. Merchandise trade flow. Now, I want to open a folder, macroeconomic indicators. So merchandise trade flow. Okay. Now, if you look at this Excel file, we have various columns in this data. We have year, variables, January, February, March, April, all the way to December. So Bank of Ghana has structured their data this way, especially for the merchandise trade flows. So every year, for a certain number of variables, and for the months, it comes out with various values for those variables. So for example, in 2023, merchandise exports less imports trade balance. January was this figure, February had this figure, March had this figure, April had this figure, and so on and so forth, all the way to December. So every year has the data of values that it has. So these values for the various months is tagged to a particular variable. So if I'm talking about merchandise imports for non-oil, it has its values. Merchandise imports for oil and gas, it has its values. Merchandise imports, FOB, has its values. Merchandise exports, it also has its values for the monthly stuff. Crude oil, cocoa products, timber and timber products, cocoa beans, gold, FOB. All of these have their various data for every month, starting from January to February. And these variables cut across all the years. So we have 2023, the same variables, 2022, the same variables. And for this, let's say I have right from 2025 to 2023. So how do we actually analyze the data to make predictions? Now, what am I trying to do? I want my machine learning algorithm to pick this data, this merchandise trade flow data, analyze it and tell me, forecast and tell me the predictions that is likely to occur in future. For example, after analyzing this data, it should tell me, oh, for the next 1 year, maybe merchandise exports, less export, the value is this. Merchandise imports, the value is this. Merchandise oil and gas, the value is this. For all these parameters, you should be able to predict to me and tell me what is likely to happen based on the existing data that we are having already, so that we don't wait for our economy to crash or something to happen before we are now trying to salvage the economy. If we can make predictions ahead and get to know that this is what is likely to happen in future, then we can put measures in place in order to correct certain things that might be uncorrectable if it's too late. So that is the whole idea. The whole thing we are trying to do. We are trying to just predict these variables for the next 12 months. So it means if I have up to 2023, I might want to decide to predict, okay, for the whole of 2024, starting from January to December, what is going to be the value for all of these variables? So we can make predictions like 1 year range predictions and get to know what values are likely to occur so that we can put measures in place to try to handle certain things that we are doing. All right, so this is the historical data we are going to use, merchandise trade flows. So let me get back to my where was I? Okay. So the data, the file size is actually 27 kilobytes. The dimension, if you check, the data I use had 188 rows by 14 columns. So it's understandable and all of that. So what is the merchandise trade balance? What do you mean by merchandise trade balance? So if you check, merchandise trade balance refers to the difference between the value of a country's merchandise exports and its merchandise imports. So if I want to find the merchandise trade balance for maybe January 2023, what I do is for January 2023, I can check. I'll check all the merchandise exports, check all the merchandise imports, and then I take the difference, and then that gives me the merchandise trade balance. So it means that the merchandise trade balance, we could have a very good trade balance or a very poor trade balance. If a country's exports is more than the imports, then it means it's actually going to help the economy. But if the imports is more than the exports, it's going to adversely affect the economy. So the formula for merchandise trade balance equals merchandise exports minus merchandise imports. So where the imports exceeds the exports, then we have a negative trade balance. But where the exports exceed the imports, then we have a positive trade balance. So, and every economy will obviously want the positive trade balance. No economy in the world would want to be importing more than it's exporting. So whenever you export more than you import, it's very good. It strengthens the currency. It strengthens the economy. But if you import more than you export, then obviously your economy will be affected. So for example, if Ghana exported 100 billion worth of goods, but imports $120 billion worth of goods, what is going to be the merchandise trade balance? It's 100 billion minus 120 billion, which is negative 20 billion. And this is a trade deficit, this is a negative trade balance, which is not going to order well for our economy. So if we can use machine learning to predict variables that has to do with the merchandise trade flows and even predict the merchandise trade balance ahead of time, and we get to know, oh, this is what is likely to be our merchandise trade balance ahead of time, then we can put in measures in place right now to prevent that from happening. All right. So that's the whole idea of what we are trying to do. So the workflow, what we are going to do is we are going, if after obtaining the data, we are going to load the data, pre-process the data, and scale the economic indicator data set. In this case, we are looking at the merchandise trade flow. We are going to train the model, and the model we are going to adopt is the LSTM model. It is actually a regression model, long short-term memory model. So after training a model, we are going to make predictions. So we'll use the training model to make futuristic predictions. Then, after making the predictions, we'll find a way to generate recommendations based on the predictions. So it's not enough to just make the prediction, but what and what can we do in order to actually help to prevent any negative trade balance that might occur or something. We need to be able to give recommendations based on the predictions. And that one, it means we'll have to use what is known as the GPT, the generative pre-trained transformer, which is also another thing we have to look at. We might not be able to look at that today, so we'll place that on hold. What we might look at is the pre-processing of data, the training of the model, making predictions, and possibly we'll convert the model to a certain file which can be used in mobile apps. So when you have done with your model, you have to convert it to a certain file or extension. And it's that extension that can be used in mobile apps. So let's see how that can be done. So log short-term memory is the model. I don't want to go into the complexities of the log short-term memory model, but that is what we are going to use for our practical task today. It's quite complicated, but bear with me. LSTM has wide applications in classification, regression, data processing, time series analysis tasks, speech recognition, machine translation, and so on and so forth. We even have financial forecasting here, as you can see. So what we are going to do is a financial forecast. Let's see how we can feed in our merchandise trade flow algorithm. So let's look at a practical activity. As you can see, this is my merchandise trade flow data set. I converted the Excel file to a CSV file. So this is what I showed you earlier on. This is the data we have. Let's see how we can process this data in order to make some predictions. All right. So let's go to Google Colab. Google Colab. Colab. Let me switch this to the accounts. So as you can see, oh, so this is a model I've already designed already, but then let's see how best we can do that step by step so that it will aid you actually properly. So we are going to use the merchandise trade flow data set. I can give you this data set later on so that you try it at your end. Also follow whatever we are trying to do and see if it works at your end. So you can just open a notebook in Google Colab, a fresh notebook. So let me just do that instead of opening this existing one. Then go to Google Drive. Need to go to Drive. Love notebooks. Yeah. So I've opened a new notebook. Let me call this merchandise, QST, merchandise, trade flows. Okay. I hope I'm still audible.
Yes, please. You are.
Yes, sir.
All right. So before we begin, we need to actually import certain libraries, but the importing of these libraries require us to perform some pip installations here and there. So as and when we'll need to do some installations, we'll do that. Usually we need to install certain libraries before we can begin whatever we are doing. So let me pip install pandas. Pip install pandas. Hope it doesn't take too long. Okay, say requirement already certified. That's because I've already installed them already. So I've installed them. So let's move ahead. Pip install numpy. This has also been installed already. All right, then it means I can just move ahead straight into my code. Whenever we need something, we can always come back. All right. So I'm going to import numpy as np. I'm going to import pandas as pd. I'm going to import matplotlib as plt from keras dot models. We're going to import sequential. These are the libraries I need. So keras, we need to install keras. Come to that. From keras dot models, keras dot layers, sorry. Keras dot layers. We're going to import lstm. Dense drop out. From TensorFlow dot keras dot regularizes. We're going to import L2 from sklearn. Import main scalar from sklearn dot metrics. Import mean squared. Come to this mean scalar. So from keras dot optimizers, we're going to import Adam from keras dot callbacks. Going to import early stopping So import TensorFlow as TF. All right. Let's move ahead. If anything is required for us to install, we'll come to PIP and install them and move ahead. So now we said we want to load the merchandise trade flow. Now the CSV file as it stands now, I've placed the file in Google Drive already. So when you place it in Google, okay. The data set, economic data, you see all the data has been placed there. It's already in my drive. So I have the merchandise trade flow .csv file already in there that I've placed. So first of all, what you need to do is to try to mount this drive so that it can be accessible in Google Colab. Other than that, you might not be able to access the CSV file there. So how do we do that? We can say from google.colab import drive, drive.mount that. So let's run this to be sure it's working. If it's not working, okay. Let's mount our drive. What is the error? It says invalid syntax. Import from google.colab. Okay. If this is going to give us an error, let's just use the file path. So file path equals that. Then data equals this. So let's specify a file path over here. So we have content/drive. I told you that the file path, your drive data set, economic data. You have to follow this file path. So we have content/drive/my drive/data set/economic data slash merchandise trade flows .csv. I'll pass the file path here, PDF will read. But before this will work, you actually will have to go and mount the drive. Other than that, you will not be able to. So you come to this side called files, then you go here, it says mount drive. So you make sure you go and mount the drive. It is only when you have mounted a drive that Google Colab can now access the particular drive and link to your file path. So you see, when it does that, the drive is loaded and everything. So let's run this command and see if it will give us error or no error. Let's see. No such file or directory, contents my drive. Let me see. Contents my drive. Okay, my drive data set, economic data. Okay. Let's see. If we take this out, what happens? No such. Drive data sets. We have to be very particular with the far part because the least mistake and then it's not going to load the data. So we need to be very careful. Drive, my drive data set. Yeah, so drive, my drive. Okay, let me see if this will work. Economic data. It's supposed to work.
Hello, Doc.
Yeah, let me.
It seems
Uh,
the economic this one. Please let's go to this one again. It seems the economic data is not in the directory that was shown.
you mean the
Hello.
merchandise trade flows?
No, the
Please, the
one which
spelling
is
of
economic.
merchandise,
Okay, the spelling of the economic data.
the spelling.
Merchandise. Oh, okay. Yeah, it's true. This spelling is different.
Yeah,
Okay.
I think you use the Z.
Yeah. All right. I think the spelling is problematic. Okay. All right. All right. So I think just a small letter. I think instead of S, I said Z. That is what was causing the problem. Okay.
Yes.
So let's move ahead. All right. So now I just call this data object that has read the whole of the merchandise trade flow CSV file. When I run it, I should be able to see the contents of the CSV file. So I'm going to see the contents of the CSV file. Everything that I showed you in that Excel file, that is what is appearing. So the first 5 items here is known as the head, and the last 5 items here is known as the tail. If I want just the head alone, that is the first 5 records or rows, then I just say that data dot head, and that gives me the first 5 records. If I want the last 5 records, then I say data dot tail, and that gives me the last 5 records. Right. We can also describe this data. Maybe you have the data is merchandise trade flow. I want to describe the data. So data dot describe. I want to describe the data. So give me a brief description of the data. It tells me the count. We have 188 rows. The mean is 21014 dot. Then we have the standard deviation is this. The minimum value is this. That's the minimum year. We have the 25th percentile, 50th percentile, 75th percentile, and all. So it gives us a brief statistics of the data that we have just loaded into the pandas object, um, into the object data. So that is how to describe your data. We can also get some information. Um, I say data.info will give us some brief information about our data. And that gives us information. Obviously, when we open the SFR, you saw that there are various columns here, variables, January the way to December, and various other data in there. So this is just a brief description or information about our data. So what is the next step after all of these descriptions? That is not the main thing we are looking at. So the next thing is we want to actually verify that the variables are present in the columns of the data frame. So we can create a variable called column because year all the columns that were in the Excel or the CSV file, I bring them here. So year variables. Okay, so we want to verify that the variables are present in the columns of the data frame. So we can define a variable as missing vars because var, so for var in column, if var not in data.columns, so if we have some variables that are missing in the columns of the data frame, what do we want to happen? We want to print a message. So we want to print a message, the following variables are missing or are not or let's just say they are missing. That will be okay. They're missing. I'm not present in the data frame. Yeah. Okay. And let's filter the data frame to include only the selected variables that exist in the data frame. var for var in call if var in data the columns filtered data equals data let's check if the filtered data frame is empty. So if filtered data empty, then can just print a message and say the filter data frame is empty. Else the filter data frame is not empty. All right, so let's run this and see if there are any errors. Okay, no errors. Wonderful. So with this, we're just trying to ensure that all the columns are in it, because all of our files that we are going to run into our model, we need to ensure it has the year variables January to December, so that in case it doesn't have any of this information, then we know that there's a problem with the data. So that is the data pre-processing that we said we're going to do. First, we collect data. After that, we need to processing. So this is the start of the pre-processing. We need to ensure the data is in the right format, the right structure. And for pre-processing of data, there are a lot of things that can be done. It is not just a matter of ensuring the structure, but even you're going to see what is happening as we move along in the data pre-processing. A lot of things could be done in there. Now that we have ensured that the columns match the various, these columns that we have that matches that of the data that we loaded into our system, let's print the shape of this data and see the shape of the data will tell us the number of rows and the number of columns. So we can print the shape. We say print shape of the filtered data frame filtered data shape. Let's run this and see. Okay, 188 by 14. Remember in the slide summary, I said we have 188 rows and 14 columns. So you see here variable, all of this is 14 columns. If you can look at them, the same happens. The same is also for the file, the Excel file, the CSV file that I showed you. So our data has 188 rows, 14 columns. All right. Now, the next pre-processing task we are going to do is, remember when I opened the file, there were some places that were showing zero values, zero values. It's not supposed to be the case. Those, we can't have zero value. There should be a value, be it positive or negative, there have to be a value. If there are no values and there are zero values, then if you're going to run that in the model, your predictions are not going to be accurate. You come out with wrong values, it might not be very, very accurate. So you need to make sure that all of these are streamlined. So, and also if your data also has the presence of NaN values, you have to also correct that as well, so that your data is in the right format. So let's see how we can create a function to replace zeros with the mean of the. So for example, let me open this Excel file. Merchandise trade flows, CSV, where we have the zeros. Since we have values for this particular variable, we have value for January, February, March, April, and we don't have any values for this. What we are going to do is we'll add these 4 values, strike the average, and then the average is what we use to feed all of these zeros we have there. So the average of these 4 values, we'll use it here, use it here, use it here, use it here, or where any place we see 0. So it is going to find the row average. So the row average of this will be used to feed the rest of the months. The row average of this will be used to feed the rest of the month. The row average of this will be used to feed the rest of the months. So that we avoid any 0 values in our data. So let's create a function that can do that. The function to replace zeros with the mean of the non-zero elements in the row Okay. So every function begins with def. Those of you who are into Python, def replace on this. Select only numeric values. This is just a comment. So we say numeric underscore row equals pd dot to underscore numeric rows, comma. There is a function, pd dot numeric is a function which accepts row and the errors equals quest. So we then calculate the mean of the non-zero elements in the row. So non-zero mean equals numeric for row. Yeah. So now replace zeros with the mean. So we say row equals row dot mask numeric underscore row equals 0, comma non zero mean. Return row so assuming the filtered data is a pandas data frame, we're going to apply the function to numeric columns only. So we say filtered underscore data equals filtered yeah. Let's run this and see if there are any errors. All right, no error. So now let's print our filter data and see what we have in there. At any point in time when you are doing this pre-processing, you need to always print out the data to see if everything is intact. That's the only way you can ensure the data is correct. Well, remember we have done, we said we are going to replace the zero values with the average of the values of the row data. So therefore, we need to display the data again to be sure that the changes has taken effect. Other than that, we might still be dealing with the zero values. So let's display this. Display the filter data. So can you see that right now there are no zero values in it again? Can you see that?
Yes,
Yes,
please.
Doc.
Yeah.
Yes, Doc.
So that is how to eliminate the zeros in the CSV or Excel file. You need to write a function that will find the average of the values of the row and apply it for the places where we have the zero values. So that is it. We are still performing data pre-processing. So activity 1 we are still doing. We need to pre-process the data, make sure everything is intact before we can even think about training the model with the data and all of that. So it's very, very important. Now, let's continue to do some shuffling. This time around, we're going to do some shuffling of the data indices. Then also, we'll now split the data into the train set and the test set. So this is how to go about it. Let's first shuffle the data indices. So indices MP random, the permutation, LEN, okay. Then afterwards, we're going to calculate sizes for the training and testing sets. So the train size equals int the length of the indices times 0.8. Then we'll split indices into training and test sets. We have train indices equals indices train size indices and test indices. All we are trying to do is just to split the training data, the data into training data and test data. So here, I'm going to use iLock to select rows by integer location based indexing. So the train data equals filter data that iLock train indices. And the test data equals filter data that iLock test indices. So let's run this. Wonderful. We have split our data into train sets and test sets. The data has been split into training set and test sets. So let's print out our training set. Printing the training set. So it's a print. Training set, training data. Print. Train data. I also print a.
Hello?
So let's print a. So this is our train data after the split. Remember the full data was 188 by 14 columns, right? After splitting it, we now have the training set or training data to be 150 by 14. All right. So basically what we try to do is that the data that we had, the merchandise trade flow, 80% has been given to the training set and 20% as a test set. So 188 rows, 80% of that is 150. So that's what we are saying. Now, let's print out the test set and see. So if we have 188 by 14 and the training is 150, then the test set should give us probably 33, 188. So no, 38 by 14 columns, something like that. 38 by 14 columns. 38 by 14. Um, hmm. Why is the size not showing? Anyway, if we want to print the size, well, let's see. We can say print test data dot ship. Listen. Okay, so 38 by 14. That is the size of the test. So we have actually done our pre-processing. We have also split the data into training and test set. The next thing actually is to now go into our create our actual model functions, some functions and some model here and there so that we can train the data. I don't know if I still have time to finish this. Madam Dorcas, do I still have time?
Yeah, hello, Dr. Nimbe. Doctor is not in yet. She's gone out,
Oh, okay.
so I think you
Oh,
have
okay.
about, let's make it 12 minutes to 50 minutes.
15 minutes. Okay. All right.
Yeah.
Then I think there's not really any time left. Maybe just if you have any questions, you can ask so that we'll continue from where we have ended. We'll continue from here next week regarding with forecasting the economic health of Ghana using um the merchandise trade flow economic indicator data set. And then we are basically looking at classical machine learning, the LSTM model. So next week we'll continue on this and actually run the model with the data and everything and see what happens. So
Please,
if
can
there's
I ask
any
you a
questions
question?
so far, kindly ask me your questions. Yeah, there are any questions.
Please, regarding the data sets, in
Yeah.
running an experiment like this, what is the minimum number of rows that you need to load so that you get some accurate results?
I'm not sure there's any number of rows. Now, prehistoric data can be very, very lengthy. We had some data that was even 1970 something. I'm not sure there's any limit like that. You just have to ensure that your data is consistent, the values are okay, and that they are not zero values, they are not any n values and all. So I don't know if there's actually a limit, but I'm not sure there's any limit. But if there's any limit to even the data size, then what you can do is some of the old data, you can just take them off and then you'll be good to go. But I don't presume that you have any challenges with loading the data into the system.
Okay, please. I'm asking this because in case you have a data set with about 62,000 rows, is it necessary to use all, or you can choose to truncate it? And what is the limit again? Once again, I have to use that word. The limit if you choose to truncate.
Yeah, so depending on the model you are using, some models can actually um, handle a lot of rows, and every model and its strength. So sometimes for historical data, some models might not have a problem if in the model size is very huge, but some models too might have a problem if the size is too huge. And therefore, if it complains that the size is too big, what you can do is you can remove some of the data, some of the years from it, and then you can still run your model. So you eliminating some of the years is not going to greatly affect your predictions actually. It's not going to affect because if you see some of the merchandise trade flow and some of the economic indicator data sets I used, what happened was that some of the data was not even necessary. So I even took them out. Some had some missing values and stuff. I took them out. And then I ran my model. So depending on the model, you might decide to use all or not. If the model allows for everything to be loaded, you can use all. If it doesn't allow for the whole data and it says you can only take some part of the data, then you have to delete some of the data and load what is acceptable. You
Okay, thank
understand?
you. Yes, please. I understand.
Yeah. So if you
No,
pick
but
the
I have a
LSTM, if you pick the LSTM model, for example, it can handle a data set of 60,000 rows. It can do that.
Okay.
It can do that. All that you need to ensure is that the data is clean, the data has been scaled properly, and there's no issues with the data and stuff. So very huge amount of data is possible.
Okay. Thank you. Please.
Yeah.
no, but I think
Okay. So
the
any other
the
question?
yeah the with regards to the test and validation, I think that is what the gentleman is trying to find out. At what ratio are you supposed to keep a test data as compared to what to keep? Because in terms of volume of data, it varies from one data set to another. So as far as the models are concerned, they can be able to contain them based on their model limit and what you're doing. But what would be the ratio of the test data for that particular data that you are supposed to work on after you have cleaned the data?
Oh, okay. Okay. So usually, I've seen people do various selections of test and training data based on I think I see some they do 80-20, some do 70-30. So all depends, as you said, all depends on sometimes the volume of data and stuff.
Hmm.
I think realistically, most of the time, people normally use the 80-20 approach. So 80 for training and 20 for test because you want your data, your model to be trained with a lot of data with all possible scenarios so that even the small you use in testing, if it's able to make predictions, then you are assured that your model is working properly. There is no way the test data should be more than the training. Always the training data has to be more so that the model can handle any possible scenarios and stuff. So usually what I see is 80-20. Sometimes I also see 70-30, but I have not really seen anyone that has gone beyond 70-30. I mostly see 80-20, 70-30. So if you decide to do it 80-20 or 70-30, I don't think that should be problematic. I don't think that should be problematic. Yeah, you will still be able to achieve your desired results. Yeah.
Thank you.
Any other questions?
Please, there are some questions in the chat section.
Oh, okay. Chat. But the more the data, the better the model, right? The better the model, right? Okay, so someone is asking if the more the data, the better the model. Yeah, if you have more data, it helps the model to be able to train better. Because no, limited data is not good. Small data, it can't possibly consider all possible scenarios. But if you have more data, your model can actually learn better and make better predictions and all of that. So yes, more data is actually good, but it depends on the activity you're also trying to perform. Some activities might not require a lot of data like that. So sometimes, but generally more data is good. So cleaning of data same as processing. Someone is asking, that is Mustafa. Is cleaning of data same as pre-processing? Cleaning of data is just a part of pre-processing. In pre-processing, there are a lot of things we can do. And one of such things we can do is called the cleaning of data. So let's say pre-processing is more of a cleaning and pre-processing of data. It's just a term. So when we are pre-processing data, what we are doing is that we are trying to clean the data, trying to structure it, make sure everything is okay. There are no zero values, there are no NaN values. All the data format and structure is intact and everything. So yeah, we can say maybe the words could be used interchangeably, cleaning, pre-processing, basically the same thing. Yeah. But then if you want to consider it, yeah, pre-processing is more of a technical term. Yeah, so yeah, that's basically it. Then also please doctor, why you didn't use validation set during the splitting? Or is it because validation set is not important? Oh, okay. I see. I see. You can decide to use a validation set. No, it's not really compulsory for you to use validation set. So, but even if you look at the model, when the we are designing the model, the validation aspect, we use a test set to actually validate the model and all. So yes, some people might have just training and test sets, some might have training, test, and even validation sets and all. So it all depends on what you want to do actually. So you are not actually obliged to follow a specific pattern. Now, it means that the validation set is, I didn't use it, doesn't mean it's not important. It's important, but you can opt to use it or not. It's up to you. But in the model, as I said, in the design of my model, the validation of the model was done using the test set. So maybe you've not gotten there yet. Maybe next week, you have a clearer picture of the model, how it looks like, and all the things that will be happening. So the zeros in the data can be replaced with NaN and write a code to drop it. Okay, so is it the zeros in the data can be replaced with NaN and write a code to drop it? Yeah, you can do that. You can drop it, but for me, I didn't want to drop the data. I actually wanted to make use of data. And if you want to make use of the data, then you have to find the average of the row, the mean of the row, and then repeat those values for where we have the zero values. So you can decide to drop those rows with the zero values, or you can decide to actually calculate the row mean and put the values where we have the zeros. That approach too is also good. So however you decide to do it, it's still okay. Yeah. Are there any other questions? Any other questions? In that case, I bring my presentation for today to a close. Next week we'll continue from where we left off, and then we'll finish up with the classical machine learning LCM model for prediction using the merchandise trade flow data set. Yeah. When we are done, the third week we'll now develop a quantum machine learning model to also train using the same data set, and we'll see how the quantum version also works. Yeah.
Can you share the data set?
Yeah, Anthony, what did you say?
Can you share your data set?
Yeah, I can share the merchandise trade flow data set with you.
Okay.
I don't know. Or should I share it on this platform or where?
You can anywhere. You can pick it from the chat. You can pick it from the group page.
Or maybe the virtual class where we normally have
Okay. I think
our
we'll put it in
materials.
the virtual class. So, Doc, you can send it to Dr. Martin so that we put it on the
Okay. Okay. So
virtual class.
I'll send the slides and I'll send the data set to Dr. Harry Martin so that he can push it on the where you guys can access it, and then at least what we have done today, you guys can follow suit, go through and also practice before we meet next week and continue from where we left off. Yeah. Okay. So over to you, Henry question. Yeah, Henry question.
Okay. Thank you, Doc. Thank you, participants, for joining today's session. I think we have we have some meetings next week, and we'll update you on the sessions that we'll be having, and also all videos will be uploaded onto YouTube and then the virtual space. So have a nice day. Thank you for.
Okay. All right. Have a nice day, everyone.
Thank you, Doug, and thank you so much. It was a
Okay.
powerful presentation.